Thank you very much, Dr. Haitham, for the invitation and introduction. My pleasure and honor to be among the distinguished leaders of Ain Shams University. Dr. Yahya, pleasure to have you in Egypt. Dear guests, I think I'll try to be very focused. My talk is about the new advances in single-shot ablation. Just a quick note, show of hand, is there anyone who's not Arab speaking? Is it okay? Yeah, because I have too many details in the presentation and I think it might be better absorbed if I say it in natural language. Okay. Okay. ميزة ان انت تبقى ثالث محاضر في presentation كلها consistent and then I can skip the introduction about indication for ablation. I'll go directly to what I need to talk. Point by point versus single shot. زي ما دكتور رانيا قالت من شويه البوينت باي بوينت كان هو الستاندرد بتاع الاي اف ابليشن لفتره. طبعا بعد كده ظهر السنجل شوت كرايو بالون تقريبا في 2010 بدات الايرلي ستاديز بتاعتها ميدترونيك وايه اللي يخلينا نتحرك ناحيه سنجل شوت فيرسس بوينت باي بوينت ابليشن. اكشلي مزايا البوينت باي بوينت هي عيوب السنجل شوت اند فايس فيرسا وتقدر تقلبهم زي ما انت شايف. بوينت باي بوينت definitely it is the standard, it is the very flexible, adjust to different anatomy. Lesion creation is very controllable and precisable وفي نفس الوقت اقدر integrated مع 3D system ده الستاندرد بتاعها وتقدر تابليت targets other than pulmonary veins. ده اللي اقدر اعمله بالبوينت باي بوينت. single shot application on the other hand ما بتقدرش تعمل الكلام دوت at least to a great extent في advances في الموضوع ده ولكن القاعده ان هي ما بتقدرش تعمله. On the other hand the single shot application are easier to learn. بتحقق لك التارجت اللي احنا اتكلمنا عليه في الاول اللي هو البالمونري فين ايزوليشن بسرعه indwelling time قليل سايد افكتس اقل والاهم من كل الكلام ده البروسيجر ديوريشن والليرنينج كيرف بتاع السنجل شوت ابلكيشن اقصر وبالتالي هي اسهل تو بيك اب اند تو ادوبت. طيب accordingly احنا عندنا اوبشنز كتيره جدا في السنجل شوت pulmonary vein isolation المين توبيك بتاعنا ومن كتر التكنولوجي احنا ممكن for the sake of this presentation نقسمهم لتو كاتيجوريز كبار. حاجه اسمها بالون based single shot ablation او tools ونون بالون based single shot. في الاخر الاثنين بيعملوا multiple lesion او around the pulmonary vein بهدف الايزوليشن ولكن في حاجات بتبقى mounted على inflatable balloons وحاجات ثانيه ما بتبقاش كده. طيب ريفيو سريع حوالين اول تكنولوجيز هي الكرايو بالون ابليشن. دي حاجه ما هياش جديده ما هياش نوفل دي حاجه موجوده من زمان جدا. عندنا تو تكنولوجيز كبار فيها الاركتيك فرونت بالون كاثيتر بتاعت ميدترونيك والبولاركس بالون كاثيتر بتاع بوسطن. The principle of creating a circumferential lesion around the pulmonary vein is the same. في الحالتين بيبقى في nitric oxide gas injected inside the balloon بيؤدي إلى drop of temperature down to -80 degrees وده بيتسبب ice formation intra and extracellular and this process causes circumferential cell death around pulmonary vein and causes isolation. Definitely زي ما قلنا في كل المزايا بتاعتها اللي اتقال كده easy fast indwelling safety profile كويس جدا و at best it is not inferior to point by point application in terms of freedom of AF. Okay, so كل الهيد تو هيد ترايلز ما بين الاثنين although ان في ترايل specifically highlighted edge for smart touch catheter بس there are other trials who highlighted ان هما الاثنين effective. الاثنين بيحتاجوا sealing and this is the technical issue with them and some anatomies are challenging than others so it is very useful but it's not a single solution for all PVI. Now the other types of balloon are the radio frequency balloon. نفس الكونسبت inflatable balloons لازم نعمل sealing around the pulmonary vein although to a lesser extent لكن ال creation of lesion بيبقى dependent على radio frequency application. أول example هي الهيليوستار catheter من بايوسنس ويبستر. البرنسبل بتاعها إن هي بتديليفر unipolar catheter. خليني I hope I can yes. Okay, it delivers unipolar radio frequency energy through these electrodes اللي بيسميهم teardrop electrodes كلها unipolar وميزتها تحديدا ان هي فيها dedicated mapping catheter وبالتالي السيجنال مش degraded بالابليشن وتقدر تبقى تتشاف على 3D mapping system في الكارتو. So you can get a visualization as you ablate. Each single electrode is irrigated and controllable independent than the other electrode. So I can switch how much energy I need to dial on the posterior wall. I can stop ablation at certain electrode and continue in other. So it's very versatile and very malleable. The thing is that it can isolate pulmonary veins quickly. However, in the early reports in Radiance trial, the incidence of asymptomatic cerebral emboli and asymptomatic esophageal erythema were significantly high. I mean, they commented it is not that high. It's at upper limit of what could be accepted, but it is high. Whether it has long-term implications or not, this is yet to be studied. The other radio frequency balloon and the other competitor is the Boston technology, the luminized RF balloon, and this is very interesting. The concept is the same. It is a balloon. It is radio frequency energy delivered over an electrode, and it has a very peculiar arrangement compared to the Heliostar. First, you have 12 equatorial electrodes and 6 forward-facing electrodes. You can apply unipolar or bipolar, and you have integrated microelectrodes for mapping. So you don't have a dedicated mapping catheter like a Thalasso and the Heliostar. The other thing is that you can use the forward-facing electrode to apply focal lesions. So it can be used for pulmonary vein isolation and theoretically, at least so far, for point-by-point ablation at the same time. It is also equipped with a real-life camera inside the balloon. So you can actually see the view inside the pulmonary vein, and this is what you see from the camera. It's important to be in contact, so this white line is the point of contact between the balloon and the wall, and this red area signifies poor contact in this lesion. So you can turn on ablation on the area where you can exactly see your contact with the tissue, and you can simultaneously monitor the formation of lesion. Now, in the early report as well, there is a very impressive, very high rate of pulmonary vein isolation, but again, it's very expensive technology and we need more studies about it. The last option, I was hesitant to include it, but it is there anyway, something called it's a hot balloon. It's almost so far exclusive to Japan, and it, again, occlusion balloon that uses thermal energy to create circumferential lesion, but the whole balloon is heated. It's not just RF delivery from surface electrode. The heating coils are present inside the balloon, and the balloon is filled with a mix of dye and saline, and that fluid becomes heated, and this heat is transferred to the tissue to create the circumferential region. Again, satisfactory early report, but no sufficient data, being only limited, having only a limited market release. Now, these are what we call the balloon-mounted technologies. The non-balloon catheters are, in my opinion, the future of AF ablation in the next years. Okay, the classic example so far is the Farapulse system from Boston Scientific. It's a whole new concept of energy. I will give it a few times because I think it's important. It's pulsed field ablation through multi-electrode catheter, and different companies have different catheter for delivering this energy. In Boston, they use the basket catheter. I will show an example, and it's very selective cardiac myocyte. This is what makes it very exciting, so that the collateral damage is almost next to zero. It's very selective for cardiac tissue, and I'll show examples. And it's also recently has been integrated with 3D mapping system, the Rhythmia of Biosense. Interestingly, it requires very heavy sedation or GA because so far this is painful form of energy delivery and lesion creation. And I will show you a quick video about the system. This is the catheter Boston uses for PFA. It's called the Farawave catheter. It's a multi-electrode catheter. It has two configurations, something called basket configuration and flower configuration. This is the system. This is the catheter in flower configuration, and it will show again in a few seconds the basket. This is the system, very easy interface. You just select the energy you need to deliver and you press deliver. You don't need 3D mapping system to perform circumferential ablation, pulmonary vein isolation, just catheter in the left atrium. It needs to be precisely placed in the pulmonary veins, in the catheter and in the flow, and according to the recommendation of the company, you need 8 applications, 4 in each configuration. You start by the basket configuration. You apply 4 lesions, 2 in first orientation like this. You apply 2 lesions, and then you rotate the catheter almost 36 degrees, and you apply another 2 lesions. Then you put the catheter in flower orientation. So this is the first orientation, the basket. Then you change it to flower orientation. 2 application, rotation, another 2 application, and this vein is isolated. This is not obviously single shot. However, the isolation usually occurs with the first application. All subsequent lesions are required for the durability of isolation rather than together. This is what makes it interesting. When you study, it's very selective for cardiac myocyte to the extent that the blood vessels and nerve inside the wall of the left atriums are intact, or at least this is what we know so far about it. And consequently, extra cardiac tissues like the phrenic nerve and the esophagus are again spared. So this is what I want to talk about, pulsed field ablation. It's a very different form of energy. RF or DC current are delivered in biphasic, usually mean, and this is called alteration of the polarity of cell membrane, which eventually causes a creation of water holes. And these water holes, when you reach certain number, they call autolysis or apoptosis of the cells and permanent cell death. You need to titrate the energy to land in the sweet spot between forming. This is what you don't want to have. You don't want to apply too much energy to create thermal injury, and you don't want it too low to be a reversible lesion. You need to land in this sweet spot where you have a non-thermal, durable electroporation. It's very safe, it's very attractive, but it has a large safety margin. It's very selective in terms of tissue, and you can see this. This is the energy you need to cause an irreversible electroporation for myocardium from animal study. And when you compare it to the energy required for collateral tissue, it's almost 3 or 4 times. This is what makes it very selective for cardiac myocytes, and the incidence of collateral damage accordingly is very low. Even in animal study, when they went extensively and opposed the esophagus to the left atrium and created huge lesion. This is the esophagus after, this is the esophagus after pulmonary vein, completely intact despite deliberate high voltage energy, and this is the esophagus in animal studies, how it is with radio frequency energy. Again, the same thing. I just need 2 minutes and very quickly. Again, it's attractive when you studied the posterior wall and the esophageal edema after cryo or point-by-point ablation. No enhancement in the esophagus as opposed to that with point-by-point or balloon cryo, even cryo. Again, because the mode of energy is not thermal, so the cell death is not inflammatory, and accordingly the extracellular structure of the tissue is preserved and the incidence of fibrosis is low. This is why the left atrial transport function is not affected with pulsed field ablation, and there is almost no incidence of pulmonary vein stenosis after pulmonary vein, despite applications that could be inside the pulmonary vein themselves. This is why there are another catheters, another company started to pick up the concept and apply pulsed field ablation on different catheter. Medtronic acquired or revived the PVAC catheter, and they just published their first studies on the PVAC on pulsed field ablation. Again, very attractive, has the same limitation of GA. Biosense Webster also are joining the race, and they have their own platform for delivering pulsed field ablation. And again, they revived the Inmark catheter that was stopped almost in 2013 to 2018 and use it as a platform for delivery of the pulsed field ablation. And they took the advantage of integrating it with CAR-T3 system. Now, this is a different concept. This is different energy. This is not the pulsed field ablation. This is a new tool for non-balloon pulmonary vein isolation single shot, which is the ultra low temperature catheter. Again, it's an extension of the cryo concept, but with a different delivery. The thing is that you use different catheter to deliver nitric oxide, but the temperature drops to very low limits, down to minus 190. You can pre-shape the catheter with nitinol stylet, so you can actually achieve CTI single shot ablation. So it's pre-shaped to do that. But the other hand, if you're planning to do pulmonary vein isolation, you need to cool the esophagus because the temperatures, so you have a dedicated warming balloon that needs to be placed in the esophagus to prevent esophageal injury. Again, globe catheter, something that was pulled from the past, again is being investigated for cryoballoon, for PFA. So my take-home message is that single-shot PVI allows for standardized PVI in relatively short procedure time, and single-shot PVI using pulsed field ablation catheter offers similar efficacy, at least from the early studies so far, to other energy forms, but with better safety profiling. This is the main selling point of pulsed field ablation. It is the safety. And since pulmonary vein isolation is the standard approach, and this is what my colleagues in previous presentation, they've all acknowledged, it is the standard approach for first AF ablation procedure, single shot PVI tool is a reasonable forced ablation option. Thank you very much.